The Bermuda Triangle. The Bermuda Triangle is one of the most persistent modern myths associated with the natural world. It occupies a loosely defined region of the western Atlantic Ocean, stretching between Florida, Bermuda, and Puerto Rico. There are no official borders, no legal recognition, and no markings on nautical charts that distinguish it from surrounding waters. Yet, for more than a century, this area has been linked to a quiet accumulation of unresolved disappearances. The earliest stories did not emerge as myths. They appeared as reports. Ships that failed to reach their destinations, aircraft that vanished during routine flights, logbooks that ended mid-sentence. In many cases, the conditions were described as normal. Weather reports showed no severe storms. Crews were experienced. Vessels were seaworthy. Communication was established, and then abruptly lost. One of the most documented cases occurred in December 1945. 5 U.S. Navy training aircraft, collectively known as Flight 19, departed from Florida on a navigation exercise. During the flight, radio transmissions indicated growing disorientation among the pilots. Compasses were reportedly malfunctioning, and landmarks no longer matched expectations. The instructor leading the group expressed uncertainty about their position. Communication deteriorated. Eventually, all contact ceased. A rescue aircraft dispatched later that day also disappeared. Despite extensive air and sea searches, no confirmed wreckage from either incident was recovered. Over the following decades, similar cases were compiled by journalists, researchers, and maritime historians. Some vessels were found drifting without crews. Others simply never reappeared. In several instances, radio transmissions ended without distress signals or indications of mechanical failure. The lack of physical evidence became a defining feature of the phenomenon. Scientific explanations have consistently focused on environmental and human factors. The Atlantic Ocean is known for rapidly shifting weather systems. Sudden storms can form with limited warning, particularly before the age of satellite forecasting. The Gulf Stream is a powerful current capable of moving debris far from its original location in a short period of time, complicating search efforts. Navigational errors, fatigue, and instrument misinterpretation have also been cited as contributing factors. Magnetic variation has been discussed as well. In certain regions, magnetic north differs noticeably from true north, requiring careful correction by navigators. While this phenomenon is not unique to the Bermuda Triangle, improper adjustment could lead to gradual but significant navigational drift, especially during long flights or voyages. These explanations address plausibility, but they do not resolve every detail. In many historical cases, records are incomplete. Wreckage was never found. Final positions were never confirmed. The ocean absorbed the evidence before conclusions could be drawn. As technology advanced, the frequency of unexplained disappearances declined. Modern aircraft are tracked continuously. Ships transmit their positions in real time. Satellites monitor weather, currents, and communication. Today, thousands of flights and voyages pass through the region each year without incident. Yet the earlier cases remain suspended in uncertainty. They occurred at a time when observation was limited and recovery was difficult. Without data, science cannot close the narrative. Can only outline what is likely, not what is certain. The Bermuda Triangle persists not because it defies physics, but because it exists within gaps of historical record. It represents a moment where human movement intersected with an environment vast enough to erase its own disturbances. There is no visible threshold when entering the region. No change in the water, no warning in the sky. The ocean remains calm, indifferent, and unchanged. This ordinariness is central to the myth. The idea that disappearance does not require spectacle. The Bermuda Triangle remains a symbol of unresolved absence. Not a supernatural zone, but a reminder that even in an age of maps and measurements, some events leave no trace behind. The Voynich Manuscript. The Voynich Manuscript is one of the most studied and yet least understood documents in human history. It is a handwritten book, created sometime in the early 15th century, composed of approximately 200 pages made from vellum. Carbon dating places its origin between 1404 and 1438, firmly within the late medieval period. Beyond that point, certainty begins to dissolve. At first glance, the manuscript appears structured and deliberate. The text flows smoothly from left to right, arranged into paragraphs, with consistent spacing and rhythm. There are no obvious corrections, no hesitation marks, and no signs of uncertainty in the writing. Whatever system was used, it was known well by the person who wrote it. The script itself does not resemble any known language. The characters repeat in patterns that suggest grammar, but they do not correspond to letters from Latin, Greek, Arabic, or any other documented alphabet. Word lengths follow statistical distributions similar to natural languages, yet no translation has ever been confirmed. Interwoven with the text are detailed illustrations. Many pages contain drawings of plants that do not match any known species. Roots, stems, and leaves are rendered with care, but their combinations feel unfamiliar. Other sections depict astronomical diagrams, circular charts, and star-like symbols. Some pages show human figures, often female, interacting with complex systems of tubes, pools, and flowing substances. The imagery feels intentional, but its purpose remains unclear. The manuscript is named after Wilfred Voynich, a rare book dealer who acquired it in 1912. Voynich believed the document held immense historical value and devoted years to promoting its mystery. From that point on, the manuscript attracted the attention of linguists, historians, cryptographers, and eventually computer scientists. Throughout the 20th century, some of the world's most skilled codebreakers attempted to decipher it. Experts who had successfully broken military ciphers during both world wars analyzed its structure. They identified consistent patterns, repetition, and positional rules. These features suggested that the text was not random. And yet, no decoding method produced a meaningful result. Several theories emerged. Some proposed that the manuscript was written in a lost natural language. Others suggested it was an encoded form of a known language, transformed through substitution or compression. There were claims that it represented an early constructed language, designed deliberately for secrecy. Each theory addressed certain aspects of the text, but none explained all of them. Another possibility was deception. Could the manuscript be an elaborate hoax? Statistical analysis complicates this idea. The internal consistency of the text, its efficiency, and its resemblance to linguistic entropy patterns are difficult to fake, especially using medieval tools. Creating such a document without modern understanding of language statistics would require extraordinary intuition. Modern technology has not resolved the mystery. Artificial intelligence systems have analyzed the manuscript at scale, searching for hidden structures, linguistic families, or encoding schemes. Some models suggest that the text behaves like a real language. Others find anomalies that resist classification. No consensus has formed. What makes the Voynich manuscript particularly unusual is not just that it cannot be read, but that it appears to want to be read. It presents itself as a textbook, a manual, or a reference work. The illustrations are integrated with the text, not decorative. Page numbers are present. Sections are organized. Nothing about it suggests chaos or improvisation. The author remains unknown. There is no signature, no dedication, no external reference linking it to a specific person or place. Its early ownership history is fragmented, reconstructed from letters and marginal notes rather than firm documentation. The manuscript has survived centuries without explanation, passing through private collections, libraries, and academic institutions. Today, it rests preserved and digitized, fully accessible, yet still silent. Science has not failed to explain the Voynich manuscript. It simply lacks the final piece of context that would make explanation possible. Without knowing the intent of its creator, the system behind the symbols, or the audience it was meant for, interpretation remains suspended. The Voynich manuscript stands as a reminder that information can exist without meaning, at least temporarily. That knowledge can be carefully recorded and yet remain inaccessible. It is not an unsolved puzzle waiting for a clever answer, but a closed system whose key may no longer exist. And so the manuscript endures, readable in form, unreadable in substance, resting quietly between language and silence. Spontaneous human combustion. Spontaneous human combustion is a phenomenon that sits uneasily between medical reports, forensic investigations, and long-standing myth. The term refers to rare cases in which a human body appears to have burned extensively without an identifiable external source of ignition. What distinguishes these cases is not fire itself, but its selective nature. The earliest accounts date back several centuries. Historical records from Europe describe individuals found reduced to ashes while their surroundings remained largely untouched. Furniture nearby showed minimal damage. Paper objects did not ignite. In many cases, the fire seemed to center almost entirely on the body. As modern forensic science developed, these reports did not disappear. Instead, they became more detailed. Investigators documented scenes where a body was severely burned, often from the torso outward, while extremities such as feet or hands remained partially intact. Floors beneath the body were scorched, yet walls and ceilings showed little evidence of fire spread. What makes these cases particularly unsettling is the lack of a clear ignition source. No overturned candles, no electrical faults, no accelerants detected. In several instances, the individuals were alone, seated, or lying down shortly before being discovered. Death often appeared sudden. Medical examiners approached the phenomenon cautiously. Fire requires fuel, oxygen, and heat. Human bodies contain water, which should inhibit sustained burning. Under normal circumstances, a body does not ignite easily. This contradiction became central to the mystery. One proposed explanation is known as the wick effect. According to this model, clothing absorbs melted body fat and acts like a candle wick, allowing slow, localized burning over an extended period. Experiments have shown that, under specific conditions, this effect can occur. Provides a partial explanation for why the fire might remain contained. However, the wick effect does not address every detail. It assumes an initial ignition source, which is often missing. It does not fully explain the extreme temperatures required to reduce bones to ash. Nor does it clarify why such events are extraordinarily rare, given how common the supposed conditions are. Toxicology reports in some cases revealed alcohol consumption, leading to theories about intoxication and reduced awareness. Yet many incidents involved individuals with no such factors present. Age, health, and lifestyle varied widely. There was no consistent profile. Fire investigators noted another anomaly: duration. The damage suggested prolonged burning, sometimes lasting hours. Yet neighbors reported no smell of smoke. Smoke alarms were not triggered. Windows were intact. The fire seemed to consume its target quietly. Because of these inconsistencies, spontaneous human combustion entered popular culture as something unnatural. Over time, the term itself became charged, implying an internal ignition. Modern science avoids this implication, emphasizing that no verified case proves true spontaneous ignition originating within the body. Still, classification does not equal closure. Many cases remain officially unexplained, filed under undetermined causes. Without eyewitnesses or complete data, investigators cannot reconstruct the exact sequence of events. The scientific discomfort surrounding spontaneous human combustion stems from its resistance to replication. Science advances through repeatable observation. This phenomenon does not offer that. Each case is isolated, rare, and unique in context. Modern living conditions have reduced the frequency of such reports. Improved fire detection, medical monitoring, and forensic techniques catch incidents earlier or classify them more definitively. Yet historical cases remain unresolved, preserved only in reports and photographs. Spontaneous human combustion occupies a narrow space in scientific discourse. It is neither accepted as supernatural nor fully explained as accidental. It exists as a category of exception, where known principles apply imperfectly. What remains is not proof of an unknown force, but a reminder of the limits of reconstruction. Fire destroys evidence efficiently. Time erodes context. When both combine, certainty becomes impossible. Spontaneous human combustion endures not as a confirmed phenomenon, but as a label applied to events that science cannot yet place with confidence. It represents the point where observation ends and inference begins. And in that quiet gap between what burned and what remains, explanation fades before mystery does. The hum, worldwide low-frequency noise. The hum is a phenomenon reported across multiple continents, described as a persistent low-frequency sound that has no clearly identifiable source. It is not heard by everyone. In fact, only a small percentage of the population appears capable of perceiving it. Those who do often describe it as a distant engine, a steady drone, or a deep vibration that seems to come from everywhere at once. Unlike ordinary environmental noise, the hum does not behave predictably. It is often more noticeable at night, when background sounds diminish. Many people report hearing it indoors more clearly than outdoors, particularly in quiet rooms. Earplugs rarely block it. In some cases, the sound feels less like hearing and more like pressure. The first large-scale reports emerged in the mid to late 20th century. Communities in the United Kingdom, the United States, Canada, Australia, and parts of Europe independently documented similar complaints. Despite geographic separation, descriptions remained remarkably consistent. Local authorities initially treated these reports as isolated noise pollution cases. Investigations were launched to locate industrial machinery, ventilation systems, power stations, or transportation sources. In many regions, no such sources were found. Measurements taken by sound engineers frequently failed to detect anything unusual, even while residents insisted the sound was present. This discrepancy became one of the defining features of the hum. Subjective experience did not align with objective measurement. In controlled environments, some individuals continued to perceive the sound while instruments recorded silence. Physiologically, low-frequency sounds behave differently from higher frequencies. They travel long distances, penetrate walls easily, and can interact with the human body in subtle ways. However, this does not explain why the hum is location-specific, intermittent, or selectively perceived. Medical researchers explored the possibility of tinnitus. While tinnitus can produce persistent internal noise, many individuals affected by the hum reported no prior hearing conditions. The sound was often described as external, directional, and environmental, not internal or tonal. Psychological explanations were also proposed. Stress, anxiety, and heightened sensory awareness can amplify perception. Yet this explanation fails to account for the shared characteristics reported by large, unrelated groups of people who were unaware of each other's experiences. In several documented cases, residents temporarily relocated and found that the sound disappeared. Upon returning, it resumed. This suggested an external factor tied to location rather than physiology alone. Some researchers investigated geological sources. Microseismic activity, underground water movement, and tectonic stress can produce low-frequency vibrations. These signals are typically below the threshold of human hearing, but under certain conditions, they may become perceptible. Even so, such activity is usually measurable, and consistent correlations were difficult to establish. Atmospheric explanations were considered as well. Temperature inversions can trap sound waves close to the ground, allowing distant sources to travel unusually far. This could explain why the hum is often reported at night. Still, this mechanism does not identify the original source of the sound. Technological hypotheses included communication systems, power grids, and industrial infrastructure operating at low frequencies. Investigations into these possibilities yielded mixed results. In some locations, partial correlations were found. In others, no technological activity matched the reported timing or intensity. What distinguishes the hum from conventional noise is its persistence without escalation. It does not grow louder. It does not lead to mechanical failure or visible effects. Its primary impact is psychological and physiological. Long-term exposure has been associated with sleep disturbance, headaches, difficulty concentrating, and a sense of unease. For those who hear it, the hum becomes part of the background of life. It is not dramatic. It does not announce itself. It simply remains, steady and unresolved. Despite decades of reports, there is no single accepted explanation. Different regions may involve different causes. Some cases may overlap with known phenomena, others may not. The umbrella term remains because no unified mechanism has been confirmed. The hum occupies an unusual place in scientific study. It is widespread yet elusive, reported consistently yet measured inconsistently, experienced personally yet difficult to externalize. Science depends on reproducibility and instrumentation. The hum resists both. It fades in and out without pattern, leaving behind testimony rather than data. What remains is a quiet phenomenon defined more by endurance than intensity. A sound that does not demand attention, but slowly erodes certainty through its persistence. The hum continues, not as a single mystery, but as a collection of unresolved experiences linked by similarity rather than explanation. It exists in the space between environment and perception, where sensation cannot be fully separated from measurement. And there, without urgency or resolution, it endures. Ball lightning. Ball lightning is one of the rarest and least understood atmospheric phenomena ever recorded. It is described as a luminous, spherical object that appears during thunderstorms, often near lightning strikes, but behaves unlike ordinary electrical discharge. Witnesses consistently report glowing orbs ranging in size from a few centimeters to over a meter in diameter, drifting slowly through the air before vanishing. Unlike conventional lightning, ball lightning does not follow a straight path. It can move horizontally, hover, descend, or even appear to pass through solid objects such as windows or walls. Its motion is typically smooth and deliberate, not explosive. In many accounts, it persists for several seconds, sometimes longer, before fading silently or disappearing with a soft sound. Historical records of ball lightning date back centuries. Early descriptions appear in ship logs, church documents, and scientific correspondence. These accounts were often dismissed as exaggerations or misinterpretations of normal lightning. The phenomenon did not fit within established electrical theory, and without reliable measurement, it remained anecdotal. As scientific observation improved, reports continued. Pilots described glowing spheres inside aircraft cabins. Homeowners recounted orbs entering through open windows and moving calmly across rooms. In some cases, ball lightning caused damage, scorching surfaces, melting metal, or shattering glass. In others, it left no trace at all. One of the challenges in studying ball lightning is its unpredictability. It cannot be summoned, controlled, or reliably anticipated. Most sightings occur during thunderstorms, but not all thunderstorms produce it. Even in regions with frequent electrical storms, documented cases remain rare. Instrumental data is limited. Ball lightning appears suddenly and disappears before equipment can be properly deployed. Photographic evidence exists, but it is sparse and often ambiguous. This scarcity of direct data has slowed theoretical progress. Numerous models have been proposed. Some suggest that ball lightning consists of plasma stabilized by electromagnetic fields. Others propose vaporized silicon particles formed when lightning strikes soil, creating a glowing aerosol cloud. Additional theories involve microwave radiation trapped within a self-sustaining structure. Each model explains certain aspects while failing to account for others. Plasma theories struggle to explain longevity. Chemical models have difficulty reproducing motion and penetration through materials. Electromagnetic models require conditions that are difficult to verify in natural settings. What complicates matters further is consistency in eyewitness reports. Across cultures and time periods, descriptions share key features: spherical shape, steady glow, slow movement, and sudden disappearance. This consistency suggests a real physical phenomenon rather than illusion or hallucination. Psychological explanations have largely been ruled out. Ball lightning has been observed simultaneously by multiple witnesses. In some cases, it has interacted physically with the environment. These interactions distinguish it from purely perceptual events. Laboratory attempts to recreate ball lightning have met with limited success. Some experiments have produced short-lived glowing spheres under controlled conditions, but these lack the stability, motion, or duration described in natural sightings. Replication remains incomplete. Modern atmospheric science acknowledges ball lightning as a genuine phenomenon, but classifies it as unresolved. It occupies a category where existence is accepted, but mechanism is not. The difficulty lies not in belief, but in verification. Science depends on repeatability and measurement. Ball lightning offers neither on demand. It appears briefly, behaves independently, and leaves before analysis can begin. As technology advances, new sensors and high-speed recording equipment increase the chance of capturing meaningful data. Yet for now, understanding remains fragmented, built from partial observations rather than comprehensive models. Ball lightning persists as a reminder that even familiar natural events, like thunderstorms, can produce outcomes that escape complete explanation. The atmosphere remains a dynamic system, capable of forming structures that challenge established assumptions. The phenomenon does not threaten, announce, or dominate. It appears quietly, briefly, and without intention. Then it is gone. Ball lightning remains suspended between observation and theory, acknowledged, documented, and still unresolved. Dark matter. Dark matter is one of the central unresolved components of modern cosmology. It does not emit light, absorb light, or reflect light, cannot be observed directly with telescopes. And yet, its presence is inferred with high confidence through its gravitational effects on visible matter. The concept emerged in the early 20th century, when astronomers began to notice inconsistencies in the motion of celestial objects. Stars at the outer edges of galaxies were moving far faster than expected. According to classical physics, these stars should have been flung into intergalactic space. Instead, they remained bound, orbiting in stable patterns. The visible mass of galaxies was insufficient to account for this behavior. Calculations showed that far more matter must be present than could be seen. This unseen mass was given a provisional name: dark matter. Over time, the evidence accumulated. Galaxy clusters exhibited gravitational effects that exceeded what luminous matter could explain. Light from distant objects was bent more strongly than predicted, a phenomenon known as gravitational lensing. Measurements of the cosmic microwave background revealed density patterns that required an invisible component to make sense. Together, these observations formed a consistent picture. Ordinary matter, everything composed of atoms, accounts for only a small fraction of the universe's total mass. Dark matter appears to make up roughly 85% of all matter in existence. Despite its dominance, dark matter interacts weakly, if at all, with known forces except gravity. It passes through ordinary matter without friction or collision. Billions of dark matter particles may be passing through the human body at this moment without leaving any detectable trace. This invisibility complicates direct detection. Specialized experiments have been constructed deep underground to shield sensitive detectors from cosmic radiation. These instruments wait for rare interactions between dark matter particles and atomic nuclei. So far, results remain inconclusive. Particle physics offers several candidates. Hypothetical particles such as WIMPs, axions, and sterile neutrinos have been proposed. Each fits certain theoretical requirements, yet none has been definitively observed. As experimental limits tighten, some models are ruled out while others persist. Alternative explanations have also been considered. Some scientists have suggested that gravity itself behaves differently on galactic scales, removing the need for dark matter. Modified gravity theories can explain certain observations, but struggle to account for all available data simultaneously. What makes dark matter particularly unusual is how well it behaves mathematically. Simulations that include dark matter accurately reproduce the large-scale structure of the universe. Galaxies form where dark matter concentrations exist. Cosmic filaments emerge naturally. Without dark matter, these models collapse. In this sense, dark matter is deeply integrated into our understanding of cosmic evolution. It shapes galaxies, governs motion, and influences the expansion of space itself. Yet it remains physically undefined. The problem is not a lack of observation, but a lack of interaction. Dark matter announces itself only through gravity, the weakest of the fundamental forces. It shapes the universe quietly, without light, heat, or sound. Modern telescopes continue to refine measurements. Particle accelerators search for indirect signatures. Space-based observatories map gravitational effects with increasing precision. Each experiment narrows the range of possibilities without delivering final confirmation. Dark matter occupies a rare position in science. It is widely accepted as necessary, supported by multiple independent lines of evidence, and still unknown in substance. Its existence is not speculative, but its nature remains open. This unresolved state does not weaken scientific confidence. It reflects the scale of the problem. Understanding dark matter requires bridging cosmology, particle physics, and fundamental theory, domains that rarely align easily. For now, dark matter remains a framework rather than an object, a solution implied by motion, presence inferred from absence. It defines the universe not by what it reveals, but by what it conceals. Dark matter does not disrupt the cosmos. It stabilizes it. It holds galaxies together silently, without interaction or expression. And within that silence, one of the universe's most significant components continues to exist without a name beyond its shadow. The placebo effect. The placebo effect is one of the most carefully documented and yet fundamentally unresolved phenomena in medical science. It refers to measurable changes in a person's physical or psychological condition that occur after receiving a treatment with no active therapeutic ingredient. These changes are not imagined. They are recorded in vital signs, biochemical markers, brain activity, and clinical outcomes. The phenomenon has been observed for centuries, long before modern medicine developed controlled trials. Physicians noticed that patients often improved after receiving treatments that, in hindsight, had no direct physiological action. Relief occurred even when the substances administered were inert. What changed was not the chemistry of the body, but the response of the organism as a whole. With the rise of scientific medicine, the placebo effect became a central control mechanism. Clinical trials began to compare active treatments against placebos to determine true efficacy. Repeatedly, a significant portion of patients receiving the inactive treatment reported improvement. In some cases, the difference between the drug and the placebo was small. In others, the placebo produced effects nearly equal to the medication. The changes associated with the placebo effect are not limited to subjective sensations such as pain or mood. Studies have documented alterations in heart rate, immune response, hormone release, and neurotransmitter activity. Brain imaging has shown that placebos can activate the same neural pathways as pharmacological agents. Expectation plays a critical role. When individuals believe they are receiving effective treatment, the brain responds accordingly. Neurochemical systems associated with reward, pain regulation, and stress reduction become active. Endorphins, dopamine, and other signaling molecules are released, producing tangible physiological outcomes. However, belief alone does not explain the entire phenomenon. Placebo effects can occur even when patients are told they are receiving a placebo. The structure of treatment, the authority of the medical context, and the ritual of care appear to matter as much as conscious expectation. The strength of the placebo effect varies widely. It depends on the condition being treated, the individual's prior experiences, and the environment in which treatment occurs. Conditions involving pain, fatigue, and neurological function show particularly strong responses. Other conditions respond weakly or not at all. Attempts to isolate a single mechanism have not succeeded. Some models emphasize conditioning, where the body learns to associate treatment cues with physiological responses. Others focus on predictive processing, in which the brain actively shapes bodily states based on expectation and context. Despite extensive research, the placebo effect resists reduction to a simple formula. It operates across multiple levels of biology, from molecular signaling to complex neural networks. No single pathway accounts for its full range of effects. This creates a paradox within medicine. On one hand, the placebo effect is powerful and measurable. On the other, it cannot be prescribed reliably. Its effectiveness diminishes when manipulated directly. It responds to authenticity, context, and subtle social cues rather than direct instruction. Modern ethics complicate its use. Deception is no longer acceptable in medical practice. Yet removing the placebo effect entirely from treatment is impossible, because it is embedded in the interaction between patient and care itself. The placebo effect reveals that the boundary between mind and body is not rigid. Physiological processes respond continuously to meaning, context, and expectation. Treatment is not solely chemical or mechanical, but relational. Science can measure the outcome of placebo effects with increasing precision. What it cannot yet explain is how belief, context, and perception translate into coordinated biological change across multiple systems simultaneously. The placebo effect remains a reminder that healing is not fully reducible to substances alone. It is shaped by interaction, structure, and interpretation. It does not contradict science. It exposes the complexity of the organism that science seeks to understand. And within that complexity, the placebo effect persists, measurable, repeatable, and still not fully explained. Déjà vu. Déjà vu is a brief and unsettling cognitive phenomenon in which a person experiences a strong sense that a current situation has already been lived through before. The experience is typically fleeting, lasting only a few seconds, yet it carries a distinct feeling of familiarity that feels immediate and convincing. The term originates from French, meaning already seen, but the sensation extends beyond vision alone. It can involve sounds, movements, conversations, or entire environments. The individual recognizes the moment as familiar while simultaneously knowing, at a rational level, that it cannot be. Déjà vu occurs across cultures, ages, and backgrounds. Studies suggest that a majority of people experience it at least once in their lifetime. It is reported more frequently by younger individuals and tends to decrease with age. The experience is usually harmless and does not indicate cognitive impairment. Neurologically, déjà vu appears to involve memory processing systems. The brain constantly compares incoming sensory information with stored memories. Under normal conditions, this process operates seamlessly, distinguishing between what is new and what has been previously experienced. In cases of déjà vu, this distinction briefly fails. The present moment is tagged as familiar without being connected to a specific memory. The brain signals recognition without providing context. This mismatch creates the sensation of having lived the moment before, even though no such memory exists. Several models attempt to explain this mechanism. One hypothesis suggests a slight delay between different sensory processing pathways. If one pathway registers information milliseconds before another, the brain may interpret the second signal as a repetition, creating false familiarity. Another explanation involves memory encoding errors. A moment may be partially processed and stored before conscious awareness occurs. When awareness catches up, the situation feels recalled rather than experienced for the first time. Déjà vu has also been studied in relation to the temporal lobes of the brain. In rare clinical cases, individuals with temporal lobe epilepsy experience frequent and intense episodes of déjà vu. This association suggests that abnormal neural firing in memory-related regions can trigger the sensation. However, most people who experience déjà vu have no neurological disorder. Brain imaging studies show no consistent abnormalities during typical episodes. The phenomenon appears to arise from normal cognitive processes operating imperfectly rather than from pathology. Psychological factors may influence frequency. Fatigue, stress, and unfamiliar environments have been associated with increased reports. These conditions can affect attention and memory processing, increasing the likelihood of misclassification between new and familiar information. Despite extensive research, no single explanation accounts for all features of déjà vu. The experience is too brief to measure directly, too unpredictable to reproduce reliably, and too subjective to isolate fully. What complicates scientific study further is that déjà vu does not impair function. It leaves no trace. Once the moment passes, the brain resumes normal processing. There is no lingering effect to analyze. From a scientific perspective, déjà vu represents a momentary desynchronization within a highly complex system. Memory, perception, and awareness operate continuously and at remarkable speed. A slight disruption can produce a powerful effect. The familiarity felt during déjà vu is not evidence of foresight or memory from another time. It is a sensation generated internally, detached from actual experience. Yet the emotional certainty it carries makes it difficult to dismiss while it occurs. Déjà vu does not signal hidden knowledge or altered reality. It reveals the way the brain constructs continuity. It shows that familiarity is not stored as a fixed record, but produced dynamically in real time. Science can describe the conditions under which déjà vu is more likely to occur. It can map the brain regions involved. What it cannot yet do is capture the precise moment when perception slips into recognition without memory. Déjà vu remains a reminder that consciousness is not a perfect recorder of reality. It is an active system, constantly predicting, matching, and correcting. In those brief moments when prediction overrides experience, familiarity appears without history. And then, just as quietly, it disappears. The Fermi Paradox. The Fermi Paradox describes a fundamental contradiction at the heart of modern astronomy and astrobiology. On one side stands the vast scale of the universe. On the other, the complete absence of confirmed evidence for extraterrestrial civilizations. Both positions are supported by data, yet they do not comfortably coexist. The universe contains hundreds of billions of galaxies, each hosting billions of stars. A significant fraction of these stars possess planetary systems. Many of those planets orbit within regions where liquid water could exist. From a statistical perspective, the conditions for life appear widespread rather than rare. Given this scale, the emergence of intelligent life elsewhere seems not only possible but likely. Even conservative estimates suggest that technological civilizations should arise regularly across cosmic time. Some would have appeared millions or even billions of years before humanity. Yet no such civilizations have been observed. No unambiguous signals. No confirmed artifacts. No structures that clearly indicate intelligent origin. This silence stands in contrast to the expectation created by the numbers. The paradox takes its name from physicist Enrico Fermi, who reportedly summarized the contradiction simply during an informal conversation in the mid-20th century. The statement itself was brief. The implications were not. Modern science approaches the paradox cautiously. It is not evidence that extraterrestrial life does not exist. Rather, it highlights a mismatch between probabilistic reasoning and observational reality. One category of explanation suggests that intelligent life is far rarer than expected. While simple life may emerge easily, the transition to complex, technological societies may involve unlikely steps. Evolution does not aim toward intelligence. It wanders, shaped by survival rather than progress. Another category considers the lifespan of civilizations. Technological societies may emerge briefly and then disappear. Catastrophe, resource depletion, or self-limitation could end their detectable phase before meaningful contact becomes possible. In this view, civilizations are separated not only by distance but by time. There are also explanations involving communication itself. Advanced civilizations may not use technologies recognizable to human instruments. Signals could be too weak, too brief, or encoded in ways not yet understood. Silence may reflect limitation rather than absence. Some models suggest that civilizations actively avoid detection. This idea does not require intent or fear. It may simply reflect efficiency. Broadcasting signals across interstellar distances requires energy with little practical return. Astronomical observation adds further complexity. Humanity has been actively listening for only a short period on cosmic timescales. The search covers limited frequencies, directions, and durations. Absence of evidence within this narrow window does not imply universal emptiness. The structure of the galaxy itself also matters. Vast distances separate stars. Even at high speeds, travel and communication require immense time. Civilizations may exist without ever overlapping in detectable ways. What makes the Fermi paradox persistent is that none of these explanations fully resolves it alone. Each addresses part of the contradiction, but leaves others untouched. Together, they form a landscape of possibility rather than a solution. Importantly, the paradox is not a mystery of missing data, but of interpretation. The universe behaves consistently with physical laws. The silence is real. The expectation is theoretical. Science continues to refine its estimates. Exoplanet surveys improve. Atmospheric analysis searches for chemical signatures associated with life. Radio telescopes grow more sensitive. Each advance adjusts probabilities without collapsing the paradox. The Fermi Paradox occupies a reflective position in science. It does not demand immediate resolution. It frames a question about scale, rarity, and perspective. Humanity exists within a small segment of cosmic history. What lies beyond that segment may not align with intuition or expectation. For now, the universe remains quiet. Not empty, but unresponsive. The Fermi Paradox remains unresolved not because it contradicts science, but because it exposes the limits of inference when observation is incomplete. And within that vast silence, possibility persists without confirmation. Near-death experiences, commonly abbreviated as NDEs, refer to a set of recurring perceptions reported by individuals who were clinically close to death or temporarily declared dead before being revived. These experiences have been documented across cultures, historical periods, and medical contexts, displaying a remarkable consistency in structure despite vast differences in personal belief systems. Reports of near-death experiences intensified with the development of modern resuscitation techniques. As medicine advanced, more individuals were brought back from cardiac arrest, trauma, or severe physiological failure. Along with survival came detailed accounts of subjective experiences occurring during periods when normal brain activity was expected to be severely impaired or absent. Common elements appear repeatedly. Individuals describe a sense of detachment from the physical body, often accompanied by the impression of observing the surrounding environment from an external vantage point. This is followed, in many cases, by movement through a tunnel-like space or passage, toward a source of light described as calm rather than blinding. Emotional tone is another consistent feature. Fear is often absent. Instead, reports emphasize feelings of peace, clarity, and emotional neutrality. Pain, anxiety, and bodily discomfort are frequently described as disappearing entirely during the experience. Some individuals recount encounters with figures perceived as deceased relatives or nonspecific presences. Others describe a panoramic review of personal memories, experienced rapidly and without emotional distress. These elements appear regardless of religious or cultural background, suggesting a neurological rather than doctrinal origin. From a scientific perspective, near-death experiences pose a challenge because they occur under extreme physiological conditions. During cardiac arrest, blood flow to the brain decreases sharply. Oxygen deprivation disrupts normal neural signaling. Under such circumstances, coherent and structured experience would not be expected. Several neurological explanations have been proposed. Oxygen deprivation can trigger abnormal activity in the visual cortex, potentially accounting for tunnel-like imagery. The release of endorphins and other neurochemicals during trauma may explain feelings of calm and detachment. Disruptions in the temporoparietal junction have been associated with out-of-body sensations. Brain imaging studies and animal models support some of these mechanisms, yet none provide a complete explanation. The timing of reported experiences is particularly difficult to reconcile. In some cases, individuals describe events that appear to occur when measurable brain activity should be minimal or absent. Another complication lies in memory formation. For an experience to be recalled, it must be encoded. The brain under severe stress typically prioritizes survival functions over memory consolidation. How detailed and emotionally vivid memories form under such conditions remains unclear. Skeptical interpretations suggest that near-death experiences occur during the process of losing or regaining consciousness rather than during complete shutdown. However, not all cases align cleanly with this timeline, leaving gaps that cannot be fully bridged by current data. Importantly, near-death experiences are not associated with lasting cognitive impairment. Individuals who report them typically show no neurological deficits afterward. The experience does not behave like hallucination caused by injury or disease. Medical science does not classify near-death experiences as evidence of consciousness existing independently of the brain. At the same time, it cannot yet map every reported feature to a specific, measurable neural event. What remains unresolved is not whether near-death experiences are real, but how they arise. They are subjectively real, psychologically impactful, and often transformative for those who experience them. Near-death experiences occupy a narrow boundary between physiology and perception. They reveal how the brain responds when ordinary regulatory systems begin to fail, yet organized experience persists. They do not confirm metaphysical conclusions, nor do they dissolve into simple error. They remain structured, repeatable, and incompletely understood. Near-death experiences endure as a reminder that the relationship between consciousness and survival is more complex than current models fully describe. And in that complexity, science continues to observe without final explanation. The wow signal. The wow signal is one of the most intriguing and carefully documented anomalies in the search for extraterrestrial intelligence. It refers to a brief but unusually strong radio signal detected on August 15, 1977, by the Big Ear radio telescope at Ohio State University. The signal stood out immediately because it matched several criteria expected of a non-natural source, while resisting all attempts at replication. At the time, the telescope was part of a passive sky survey, scanning radio frequencies for narrowband signals that might indicate artificial origin. The system automatically printed data onto long sheets of paper. Among rows of ordinary background noise, one sequence was different. The signal rose sharply above the surrounding noise, peaked, and then faded exactly as expected from a fixed point in space passing through the telescope's field of view. It lasted approximately 72 seconds, corresponding precisely to Earth's rotation and the telescope's design limitations. When astronomer Jerry Emin reviewed the printout days later, he circled the unusual sequence and wrote a single word beside it: "Wow!" The name remained. The signal was narrow in frequency, concentrated near the hydrogen line at 1420 MHz. This frequency holds special significance in astronomy, as hydrogen is the most abundant element in the universe. It has long been considered a logical place for intentional interstellar communication to occur. Natural sources were immediately considered. Pulsars, quasars, and other known astrophysical phenomena were evaluated. None matched the signal's characteristics. The intensity, bandwidth, and temporal profile did not align with any established natural process. Terrestrial interference was also investigated. Satellites, aircraft, and ground-based transmissions were ruled out based on frequency regulations and signal behavior. At the time, no known human technology transmitted signals of that nature in that band. What distinguishes the wow signal from other anomalies is the quality of the data. It was clean, well-formed, and consistent with theoretical expectations for a distant, non-repeating source. And yet, it appeared only once. Follow-up observations began almost immediately. The same region of the sky was monitored repeatedly over months and years. No similar signal was ever detected again. The absence of repetition complicated interpretation. Later analyses proposed alternative explanations. One hypothesis suggested that the signal originated from a cloud of hydrogen illuminated by a passing comet. Subsequent studies questioned this explanation, noting inconsistencies in timing and signal structure. The debate remains unresolved. Technological limitations of the era also play a role. The telescope could not track objects actively. It listened passively as the sky moved overhead. If the source was transient or directional, it may have simply never aligned again. The wow signal exists in a unique evidentiary state. It is neither dismissed nor confirmed. It does not meet the criteria for proof, but it exceeds the threshold of trivial anomaly. Modern SETI efforts have expanded dramatically. Telescopes are more sensitive. Data processing is continuous and automated. Yet no signal identical to the wow signal has been recovered. Its persistence in scientific discussion comes not from speculation, but from restraint. The data was preserved. The analysis was cautious. Claims were limited to what could be supported. The signal does not demand interpretation. It does not announce intention. It simply exists as a recorded event that fits expectations without explanation. In science, repetition is essential. Without it, certainty cannot form. The wow signal offers clarity without continuity. It remains a single moment of alignment between instrumentation and anomaly, preserved on paper and memory. The wow signal continues to occupy a quiet place in scientific history, not as evidence of contact, but as a reminder that observation can sometimes exceed explanation. And in that silence after detection, meaning remains suspended. The Mandela Effect. The Mandela Effect refers to a phenomenon in which large groups of people share the same false memory about an event, phrase, image, or historical detail. These memories are not vague impressions. They are often described with confidence, emotional clarity, and specific detail. What makes the phenomenon unusual is not individual error, but collective agreement around something that did not occur as remembered. The term originated in the early 2010s, when many people reported remembering that Nelson Mandela had died in prison during the 1980s. In reality, Mandela was released in 1990 and lived until 2013. Despite clear historical records, the false memory was widespread and persistent. Since then, similar cases have been identified across popular culture, geography, and everyday knowledge. Logos remembered differently than they exist. Famous quotes recalled inaccurately by millions. Events placed in the wrong time period with strong certainty. These shared inaccuracies follow no obvious pattern of education, nationality, or age. From a scientific perspective, memory is not a recording device. It is reconstructive. Each time a memory is recalled, it is rebuilt from fragments rather than replayed intact. This reconstruction is influenced by expectation, context, repetition, and social reinforcement. The Mandela Effect highlights how this process operates at scale. When many individuals are exposed to the same cultural material, the same errors can propagate and stabilize. Repetition across media, conversation, and shared assumptions reinforces incorrect versions until they feel original. Neuroscience shows that confidence in a memory does not correlate with accuracy. Emotional certainty can strengthen a memory even when it is false. Once formed, such memories resist correction, because contradictory information creates cognitive discomfort. Social factors play a critical role. When individuals discover that others share the same false memory, validation occurs. The memory feels reinforced rather than questioned. This communal agreement gives the impression of authenticity. Digital culture amplifies the effect. Online platforms allow people to compare memories instantly. Patterns emerge quickly. A false memory once held privately becomes part of a perceived collective experience. Some explanations focus on schema errors. The brain organizes information into templates. When details are missing or ambiguous, the brain fills gaps with the most statistically likely version. Over time, the constructed version replaces the original. Language also contributes. Common phrases are altered to sound more natural. Branding simplifies visually complex designs in memory. Repetition of altered versions gradually overwrites accurate recall. Importantly, the Mandela Effect does not require misinformation campaigns or intentional manipulation. It arises naturally from how memory functions in social environments. Despite popular speculation, science finds no evidence that the phenomenon indicates parallel realities or altered timelines. Such interpretations arise from the emotional weight of certainty rather than from empirical data. What remains unresolved is scale. Individual false memories are well understood. Collective false memories of this consistency and breadth are harder to model precisely. No single mechanism fully explains why certain inaccuracies spread while others do not. The Mandela Effect reveals that memory is not anchored to truth, but to coherence. The brain favors narratives that fit existing structures over those that are strictly accurate. Correction does not always erase the false memory. Often, both versions coexist, creating cognitive dissonance rather than resolution. The phenomenon does not indicate malfunction. It reflects efficiency. Memory evolved to prioritize meaning and continuity over precision. The Mandela Effect persists because it aligns with how human cognition operates under shared cultural exposure. It remains not as a flaw to be eliminated, but as a window into the collective construction of reality as experienced by the mind. And within that shared construction, certainty can exist without accuracy. Consciousness. Consciousness is the most familiar aspect of human experience and at the same time the least clearly defined. It encompasses awareness, perception, thought, memory, and the continuous sense of being present. Every observation in science is filtered through it, yet consciousness itself resists direct observation. Neuroscience has mapped many of the brain's functions with increasing precision. Specific regions are associated with vision, language, movement, and emotion. Damage to these areas produces predictable effects. Consciousness, however, does not localize so easily. There is no single structure that can be isolated as its source. Brain imaging shows patterns of activity correlated with conscious states. Wakefulness, sleep, anesthesia, and coma each produce distinct neural signatures. Transitions between these states can be measured in electrical rhythms and metabolic changes. Yet correlation does not establish causation. One of the central difficulties lies in definition. Consciousness is not a single process, but a collection of interacting functions. Awareness of the environment, awareness of the self, and the ability to reflect on experience can dissociate under certain conditions. These dissociations complicate attempts at a unified model. Some theories describe consciousness as an emergent property. According to this view, when neural complexity reaches a certain threshold, subjective experience arises naturally. Other models emphasize information integration, suggesting that consciousness corresponds to how information is processed and unified across the brain. Despite theoretical diversity, no model has achieved consensus. Each explains certain features while leaving others untouched. None can fully account for subjective experience itself, the quality of sensations, thoughts, and emotions as they are felt internally. This subjective aspect, often referred to as qualia, remains particularly resistant to scientific explanation. Physical processes can be described objectively. Subjective experience cannot be directly accessed by external measurement. Science can observe behavior and neural activity, but experience itself remains private. Clinical cases further complicate the picture. Individuals in vegetative or minimally conscious states may show signs of awareness despite limited responsiveness. Advances in neuroimaging have revealed hidden cognitive activity in patients previously thought to lack consciousness entirely. Conversely, highly complex neural activity can occur without reported awareness, such as during certain forms of automatic behavior or deep sleep. These observations suggest that consciousness is not simply a matter of neural complexity or activity level. Artificial systems add another layer of uncertainty. Machines can process information, recognize patterns, and adapt to inputs. Whether such systems possess any form of consciousness remains unresolved. Current science cannot establish criteria for determining subjective experience outside biological organisms. The evolutionary origin of consciousness is also unclear. Conscious awareness does not directly improve survival in obvious ways. Reflexive and automatic processes often operate faster and more efficiently. Why subjective experience emerged at all remains an open question. Philosophically, consciousness challenges reductionism. Breaking systems into parts has been successful across science. Consciousness appears to lose something essential when fragmented. The whole seems to be more than the sum of its components. Despite these challenges, progress continues. Research into neural synchronization, global brain networks, and altered states of consciousness refines understanding. Each discovery clarifies structure while leaving essence unresolved. What science can describe are the conditions under which consciousness appears and disappears. It can map transitions, disruptions, and correlations. What it cannot yet explain is why these conditions produce experience rather than silence. Consciousness does not behave like a substance. It has no mass or location. It changes without physical movement. It persists through continuous neural turnover. It is both dependent on the brain and not fully reducible to it. Consciousness remains an unresolved frontier, not due to lack of effort, but due to the nature of the phenomenon itself. It is the medium through which knowledge is obtained, yet it cannot be fully placed within that knowledge. Science continues to approach it indirectly, tracing outlines rather than capturing form. And within those outlines, experience continues uninterrupted, present, and unexplained. The Tunguska Event. The Tunguska Event refers to a massive explosion that occurred in the early morning hours of June 30, 1908, over a remote region of central Siberia near the Tunguska River. It is considered the largest impact-related event in recorded human history, despite leaving no confirmed impact crater behind. Eyewitness accounts from local inhabitants describe a blinding flash of light crossing the sky, followed by a powerful shockwave. The explosion was intense enough to knock people to the ground at distances of tens of kilometers. Windows shattered hundreds of kilometers away. Seismic stations across Eurasia recorded the disturbance. In the immediate aftermath, the affected region remained inaccessible. The area was sparsely populated, difficult to reach, and largely ignored due to political instability and limited scientific infrastructure. As a result, no formal investigation occurred for nearly 2 decades. When the first scientific expedition reached the site in 1927, researchers encountered an unexpected scene. Over 2,000 square kilometers of forest had been flattened. Trees lay radiating outward from a central point, stripped of branches and bark. Yet at the apparent epicenter, some trees remained standing, scorched but upright. No impact crater was found. No large fragments of meteorite were recovered. This absence complicated interpretation. Typical impact events leave clear geological signatures. Tunguska did not. Early hypotheses varied widely. Some proposed a large meteorite explosion in the atmosphere. Others suggested a comet composed primarily of ice. Alternative explanations emerged over time, ranging from natural gas eruptions to electrical phenomena. Most were eventually discarded due to lack of supporting evidence. The leading scientific model today describes an airburst. According to this explanation, a cosmic object entered Earth's atmosphere at high speed and disintegrated before reaching the ground. The resulting explosion released energy equivalent to several megatons of TNT, flattening the forest below without creating a crater. This model explains many observations, including the radial tree pattern and the absence of large debris. It does not, however, account for all details. Microscopic particles consistent with extraterrestrial material have been found in soil samples, but their distribution is uneven and inconclusive. Another unresolved aspect involves atmospheric effects. In the days following the explosion, skies over Europe and Asia glowed unusually bright at night. Nighttime visibility increased dramatically. These phenomena suggest the injection of fine particles into the upper atmosphere, but their precise composition remains uncertain. The remoteness of the region limited data collection. By the time researchers arrived, environmental processes had already altered the site. Fire, regrowth, and erosion obscured original evidence. The event could not be observed again or reconstructed fully. Computer simulations have improved understanding. Models of high-altitude explosions produce results similar to the observed damage. Variations in entry angle, speed, and composition can reproduce different aspects of the Tunguska pattern. Yet simulations depend on assumptions that cannot be verified retrospectively. What distinguishes Tunguska from other impact events is not just its scale, but its ambiguity. The cause is broadly accepted, but the specifics remain open. Size, composition, and exact altitude of the explosion are still debated. The event highlighted Earth's vulnerability to cosmic hazards. Tunguska occurred over an uninhabited region. Had it happened over a major city, the consequences would have been catastrophic. Despite its violence, Tunguska left no lasting physical marker beyond the forest itself. No crater, no monument of stone, only patterns of destruction and regrowth. In the decades since, the forest has largely recovered. New trees stand where old ones fell. The landscape no longer bears obvious scars. What remains is the record, written testimony, flattened maps, measured anomalies. The Tunguska Event exists at the edge of explanation. It is understood in principle but not in detail. The data is sufficient to define the phenomenon, but insufficient to close the case. It remains a reminder that large-scale natural events can occur without warning and leave behind uncertainty rather than clarity. And in that uncertainty, Tunguska continues to occupy its place in scientific history. Observed, modeled, and still not fully resolved. Sleep paralysis hallucinations. Sleep paralysis hallucinations occur during a transitional state between wakefulness and sleep, when the body remains immobile while the mind becomes partially or fully conscious. This condition is temporary, but the experiences associated with it are often vivid, detailed, and emotionally intense. During normal sleep, the brain cycles through distinct stages. One of these is REM sleep, a phase characterized by rapid eye movement and heightened brain activity. During REM sleep, the brain inhibits voluntary muscle movement, preventing the body from physically acting out dreams. This paralysis is a protective mechanism. Sleep paralysis occurs when this mechanism persists while consciousness returns. The individual becomes aware but cannot move or speak. Breathing feels restricted, though it continues normally. This mismatch between mental awareness and physical immobility creates a state of heightened sensory sensitivity. Hallucinations often accompany this condition. These experiences can be visual, auditory, tactile, or a combination of all three. Figures may appear in the room. Sounds such as footsteps, whispers, or mechanical hums may be perceived. Sensations of pressure on the chest or presence nearby are commonly reported. Neurologically, these hallucinations are understood as dream imagery intruding into waking consciousness. The brain remains partially in a dream-generating mode while sensory input from the environment is integrated inaccurately. The result is an experience that feels externally real but originates internally. The emotional tone of these hallucinations is often fear. The amygdala, a brain region associated with threat detection, remains active during REM sleep. When consciousness returns under these conditions, the brain may interpret the paralysis itself as danger, intensifying emotional response. Cultural interpretations of sleep paralysis hallucinations have existed for centuries. Across different societies, similar experiences have been described using different symbolic frameworks. Despite variation in explanation, the core features remain consistent: immobility, presence, pressure, and fear. Scientific study shows that sleep paralysis is more likely to occur under certain conditions. Irregular sleep schedules, sleep deprivation, stress, and disrupted circadian rhythms increase its likelihood. It can occur in otherwise healthy individuals and does not require underlying neurological disease. Brain imaging studies suggest that the boundary between dreaming and waking is not always sharply defined. Consciousness can emerge before the brain fully exits REM sleep. In these moments, perception becomes unstable, blending internal imagery with external awareness. Importantly, hallucinations during sleep paralysis are not random. They follow recognizable patterns. Human-like figures are common. Movement is often slow or distorted. Sounds may seem distant or muffled. These features reflect dream logic rather than waking perception. The inability to move intensifies the realism. Because the body cannot respond, the brain receives no corrective feedback. The hallucination remains unchallenged, allowing it to persist longer than a typical waking illusion. Episodes usually last seconds to minutes. Resolution occurs when the brain fully transitions to wakefulness or back into sleep. Muscle control returns abruptly. Hallucinations fade quickly, often leaving a lingering sense of unease. Despite their intensity, sleep paralysis hallucinations are not harmful. They do not indicate psychosis or loss of reality testing. Individuals experiencing them are aware afterward that the events were not physically real. What remains unexplained is why the brain generates such consistent imagery across individuals and cultures. While mechanisms are understood, the specific content of hallucinations shows remarkable similarity. Sleep paralysis reveals how fragile the boundary between waking reality and dreaming truly is. Consciousness can emerge before the brain's protective systems disengage. Perception becomes detached from physical input. The experience demonstrates that the sense of presence, threat, and reality can arise entirely from internal processes. Sleep paralysis hallucinations do not represent malfunction, but overlap. Two states briefly coexist, and in that overlap, the mind creates experiences that feel undeniably real, even in complete stillness. Ending. Some mysteries remain not because they resist investigation, but because they exist at the limits of human understanding. Science continues to describe the patterns, measure the signals, and map the mechanisms, even when final answers stay just beyond reach. These myths are not failures of knowledge. They are reminders of how much remains unexplored. If this calm journey through the unknown helped you relax, consider supporting the channel with a like and a subscription. Share your thoughts in the comments. Which mystery stayed with you the longest? And if you found this video worth revisiting, feel free to share it with someone who enjoys falling asleep to science and unanswered questions. Until next time, rest well.